Hi, I'm Paul Van Rijn. I teach mathematics at Green Acres, 7th grade and 8th grade, and I'm also an advisor for the 7th grade. In theory, there are roughly 4 phases to solving a problem, whether it's in math, in science, or in life itself. These are understanding the problem, thinking of ways to solve the problem, and then working out the solution to the problem and checking that your solution is reasonable and that it works. In terms of understanding the problem, I teach my students, or I help my students read for mathematical information. Quite often problems are story-based or contextual, and the underlying mathematics and the given numerical information needs to be distinguished from the setting of the problem itself. I also point students to earlier problems that we did that might serve as models for the new problem. This activates their prior knowledge and will allow them to look for any similarities as well as better understand any differences or new conditions. In terms of thinking of ways to solve a problem, I expose my students to various methods with the goal of making an algebraic approach accessible. Quite often students will start off with making a diagram to visualize the situation, or they work on an organized guess and check table where they work through the problem numerically, not necessarily to arrive at a correct solution, but to better understand the problem and then be able to define a variable and possibly formulate an algebraic equation that represents the physical setting. Sometimes I encourage my students to work backwards with a possible solution to see how far they can get that way. Other times we might work on mathematical investigations with the focus of finding patterns of mathematical thinking that lead to generalizations. For example, that's how my students learn binomial expansion and factoring. They start out numerically with what they know. They work through problems to look for patterns of mathematical thinking to form possible hypotheses and then verify those ideas with subsequent problems. And then we finish it up with a discussion of results and a formalized summary of what they found. In terms of working out a solution, I emphasize to my students that it's important to document their thinking so that they can explain it to a classmate or to the class when we discuss alternative methods to solve a problem. In that way, it's sort of like writing a coherent paragraph. I give models for that, besides, like I said, pointing them to their earlier work. Last but not least, I teach my students specifically how to check their answers mathematically so that they know that their answer is correct. But before that, I encourage them to see whether their answer is reasonable, because I want them to know when their answer simply does not make sense. I also encourage them to check with their classmates so that they can look for each other's and their own mistakes when there is a disagreement to an answer. Problem solving, in a way, is about taking risks. Students put themselves out there when they work on difficult problems that require more conceptual and abstract thinking. So at the beginning, I make the work low stakes so that students feel comfortable and are willing to try. I also refer them back to their earlier work to deepen their understanding of those problems and also to expand their horizons while they work on the new ones. When it's time for problem-based assessment, I provide my students with similar problems so that they sort of realize that they've seen the various methods and they know what to expect on the test. By that time, they should feel comfortable enough with the various procedures because they've worked on a sufficient number of problems that follow a similar kind of format. I also write stories with certain characters that sort of repeatedly come back so that students have this sense of recognition. And I try to make my story problems like interesting or funny in a way to create a positive disposition towards the work itself. One of our main goals as educators is to help students become independent thinkers and learners. So in math class, I expose my students to lots of challenging problems. They evaluate information, they ponder alternative strategies, they organize their thinking, they write it up, and then they sort of reflect on their results. Now these are life skills that develop their metacognitive abilities and that are transferable to other academic settings or to their personal lives. My goal is to be able to remove myself from the problem-solving process and have students rely more and more on each other and on themselves.